Hello students, in this video we have fifth illustration of chapter 6 and there are four different questions. The first one is a closed loop is held stationary in the magnetic field between the north pole of two permanent magnets and held fixed. Can we hope to generate current in the loop by using strong magnets? So the situation we are talking about uh, is like this. You have a loop and outside we have two magnetic poles. So definitely field lines are passing through this loop, but there is no change in flux. So even if magnet is made stronger, there will not be any change in flux. And then according to Faraday's law, if delta phi is 0, there is no induction. So we cannot expect any induced EMF in this case. Second question, a closed loop moves normal to the constant electric field between the plates of large capacitor. Is a current induced in the loop when it is wholly inside the region between two capacitor plates, when it is partially outside the plates of capacitor, the electric field is normal to the plane of the loop. So due to change in electric field, we cannot expect any induced EMF. EMF is induced due to change in magnetic field, magnetic flux. So what we are talking about here is this condition. You have two plates of parallel plate capacitor. So if one is positive, other one is negative, and then you have field lines going from positive to negative, and inside that we are moving a loop. But whichever way you move the loop, you are moving it in electric field, and so we cannot expect induced EMF. Next one, a rectangular loop and a circular loop are moving out of uniform magnetic field as shown in figure uh, with constant velocity. In which loop do you expect the induced EMF to be constant during the passage out of the field region? So this is the figure we are talking about. Let me draw it again. Consider magnetic field lines to be going inside like this. And now in this case we have a loop like this. So what will happen? As I move the loop, the condition will be as you drag it out, initially some part of the loop will go out. Say this much part has gone out, so there is some change in flux. After some moment, you will have a bit more part going out, but the rate at which this area is going out will remain constant. So delta phi by delta t will be constant, and hence induced EMF will be constant, provided that velocity is uniform. But if I consider circle, if I consider loop, so what happens in case of loop? Initially, we assume that the loop is inside. Okay, let this be the initial situation. After some time, part of this circle will go out, and then correspondingly there is some change in flux. Assume that this is the condition after some time when this much part of the loop has gone out. So suppose in 1 second this much part has gone out, so there is some change in flux, and then again in next 1 second, if you look at the situation, uh, we can see that more part of the loop is outside, say this much part. But then the delta phi in this case, change in flux in this case, and change in flux in this case will not be same, and hence induced EMF delta phi by delta t will also not be same. So we can say that induction will be constant here, induction will not be constant here. That was the question C. Coming to D, predict the polarity of capacitor in situation described by figure 6.5b. This is the situation we are talking about. So as the north pole is approaching the loop, the induced north pole must be on left side, and induced south pole must be on right side. And it would be possible only if A is positive, B is negative. To visualize it in other way, what you can do is consider a rectangular loop and let north pole be approaching it. So if I label it as A, B, C, D, uh, the current has to be from A to B to C to D. Okay, then only the induction will be in such a way that north is here, south is here. As north is approaching, the loop will try to oppose the change, and for that left side has to be north pole. Now you can place capacitor anywhere, maybe here or maybe here, and you can determine upper plate will be positive or lower plate will be negative. As far as answer here is concerned, A is positive, B has to be negative, then only it will be able to oppose the external change. So that is all about this illustration. Thank you.